Hello, good morning. My name is Samuel. Alright, so I'll be taking you through a series of course for those who want to learn mathematics. So this will just be, I'll be teaching you all the topics, the 39 topics. And today's lesson will be on indices. Okay. For more informations, I would let us know about other informations later. But now let's just go directly into the lesson. So I'll be starting with indices. So first of all, I'll write out the laws, then I'll explain immediately after each of these laws. So you probably have been taught this before, but I actually want you to pay attention because I'm sure there are things that you may not have come across. And if you have come across them, then it's an opportunity for you to actually revise what you have learned. Now, when it comes to indices, now for law 1 is when you have a number with a power multiplied by the same number rather, and with another power, it means the base numbers are actually the same. What you can do is you can actually add the powers together. Get that? So I'll give an example of that. So assuming you have to simplify 4 raised to power 2 times 4 raised to power 3. So this can become 4 raised to power 2 plus 3. So you have 4 raised to power 5. If you actually do this in a calculator, you know that that is actually the right answer. So let's do some other questions. Now if you have 5x squared times 4x raised to power 4. Now what you should do in this case to avoid confusion is actually I would advise you separate them, because we have constants and you have variables. Now you can do it this way: 5 times 4. Then you could have done it straight away, but you understand why I did that as soon as we go on, because there are some questions that might be complex that might require you to do that. So 5 times 4 is 20. Then you have x raised to power. These are the same base. Then you can combine them. You have 2 plus 4. So you have 20x raised to power 6. So this will be your final answer. Okay, that's we evaluated that. So, and then to the next. Alright, so I'll go to the next page. So now this next question, it's quite simple actually. So you have to evaluate 6 times 10 raised to power minus 4 times 2 times 10 raised to power 6. Now you do the same here. So you separate the ones, the whole numbers or other numbers. Then you bring the index ones together. So power 6. So this will give you 12 times 10 raised to power minus 4. Then the multiplication becomes addition. Then you have 6 in the power. So you have 12 times 10 raised to power. So minus 4 will give you that is 2. Okay, so this will be 12 times 100. So you have this as your answer. Alright, so just by the way, in case for those who have issues with additions and subtractions, now when you are adding, now if I say 6 minus 4, you probably might not have issue with that. But if you say minus 4 plus 6, someone might have issue with that. Someone might say this is minus 2. Someone might say this is plus 2. Different answers. Alright, but there's a simple way to actually go about this, which is, now think of negative as a debit and addition as credit. So if I say you have a debit of 4 and then you have a credit of 6, So will you used to be in debit, or you have left? I don't know if you understand that. So will you have extra left, or will you still be in deficit? So that's what I'm saying. You can look at it like money. So if you just see, like I was saying, see it as maybe you have -$4 plus, then that is you spent $4, then you got $6, or you borrowed $4, then you paid back $66. Is it that will you get a change, or you are still owing? I don't know if you get that. So imagine you purchase something of 4 naira, and then you give 6 naira. It means you have a change, right? Okay. So just sit like that. But then imagine you have, or let's say you have -4 -6. Now this, it means you made a purchase of 4, another purchase of 6, or you're saying you have a debit of 4, a debit of 6. It means you are now in a debit of what? A total of 10. Do you get that? Now you could use number line for this, but I'm just giving you a simple way to go about it. You get? So a debit of 4, debit of 6, it means you have a debit of 10. Do you get that? So we have let's say debit of 4, then 2. So this will give you now what? A debit of 2. So you have a 4 debt, you added 2, or you paid 2 back. So you are now left with what? 2 as a debit. I don't know if that's clear to us. So I will just continue from there. If you have any other question or you don't understand, you can just let me know in the comment section. So I'll go straight to the second law. So we have law 2. So it's similar to the first one. It's p raised power x, but division you have p raised power y equals p raised power x minus y. Now there's this way I was taught, which is the way I also like to teach you, is that times becomes plus, division to minus. We actually have a song for that. Times to plus, division to minus. Times to plus, division to minus. Well, it can help you remember things. I believe that songs helps a lot when it comes to mathematics, or on other things as well. So let's just go straight to the example. So you have to simplify. So simplify 5 raised to power 3 divided by 5 raised to power 2. Now this will just be straight away, since they are the same base. So you put 3, division will become what? Minus, and then you have 2. So this will give you straight away, this will give you what? 5 raised to power 1, which is what? Equals to, you have 5. Then the second one is you have to evaluate. Okay, let's just go to another page. Evaluate. So we have to evaluate 48 x raised to power 4 y raised to power 2. Now divided by 6 x raised to power 2 y. So in this case, like I said, you can do it straight away because everything has actually been arranged. But I'll just do it the way I would normally do it if it was not arranged. So you separate them. You bring the x together. You bring the y's together. Now this y, you know there's a power of 1 there, even if it's not there. So 48 over 6 will give you 8. Then you have x, you combine that. Now this is division, becomes minus. Then y, you have 2, it becomes minus. So you have 8. So you have x raised to the power of 2, y raised to the power of 1. So this will be our answer. So the next one, you have to evaluate 30 10 raised to the power minus 4. Alright, that said, after this we'll solve some miscellaneous y questions. Also, just to say this, I would be solving some yearly y questions but those ones will be long videos anyway, but if you are interested, you can watch them. So I'll be solving yearly. I will be solving all the questions, the objective separately and the theory separately. So as you prepare for your exam, make sure you stay tuned and subscribe and hit the bell notification. Alright, let's continue. Now this one you can just do it straight away. So you have 6 here, this will give you 5. So you have 5 times, you have 10 raised power. Now let's pay attention here. You have minus 4. Now this division will become minus, but then the power of the denominator already has a minus. So the right thing to do is what? To use a bracket. Do you get that? Now don't try to add it just by looking at it, say minus 4 minus 5. No, you would make mistake. Or maybe you may not, but some might, if you are not that good to know that. So you have 5 times 10 raised power minus 4. Now multiplication times multiplication, or minus times minus, will give you plus 5. Then you have 5 times 10 raised power. So minus 4, deficit of 4, plus 5. So you have 1 left. So you have 5 times 10, which is 50. Alright, so by the way, so let me say something about multiplying signs. So in case you don't know, minus times minus will give you plus. Plus times plus will give you plus. Minus times plus will give you minus. Plus times minus will give you minus. So it's simple as that. So let's do one more question on this. Okay, that's all. Let's just go to the next law. The next law is quite simple. So p raised power of 0 equals 1. That is, anything actually raised power 0 is 1. 1 million raised power 0 is 1. 1,000 raised power 0 is 1. Alright, so that's that for law 3. Then law 4. Law 4 states that when you have p q raised power of n, you have p raised power n times q raised power n. Now it means you can actually open it, and because p has a power of 1, 1 times n will give you 1. Q has a power of 1. 1 times n will also give you 1. Okay, so let's do some example on that. Alright, so you have we have to simplify for x y square raised power 3. Now what you do here is what? You just open it straight away. You have 4 raised power of, that's a 1, that's 1, right? So 1 times 3 will be 3. Then times x, the x also has a power of 1. 1 times 3 will also give you 3. Then y has a power of 2. So 2 times 3 will give you what? 6. So that will give you 64. X raised power of 3. Y raised power of 6. So that is that. Simple as that. So now the second one under that, you have, so let's try this out. We have simplify minus 3a raised power of 2 b raised power of 3 all raised power of 4. Now I'm going to say something before I continue. Maybe you don't know it, maybe you do. Now, when you have a negative, let's say you have minus 1 raised power n. Now when n is positive, then your result will be what? Your results will be positive. Okay, so now when n is negative, your result will also be what? Will be negative. Now, what do I mean by that? So you have minus 1 raised to the power of, let's say, 6. Now this will just give you what? 1, which is plus 1. Okay? Because the power is even, you have a positive answer. Now let's say minus 1 raised to the power of 13. Now this will give you what? Minus 1. Do you get that? As long as the number is even, you have positive. With this odd, you have negative. So now let's solve this question. Alright, so we have to simplify. Minus 3 a raised to the power 2 b raised to the power 3. So because we have known that the power is even, right? So it means the minus will actually go away. Our result will be a positive number. So now it means we can do away with that. So 3 raised to the power 4, that is 1 power of 1 times power of 4, then times a raised to the power 2 times 4, that's 8, b raised to the power 3 times 4, that's 12. So it means we will have what? 81 a raised to the power 8, b raised to the power 12. Alright, so that's that. So let's do one more on this before we go to the next one. So we have, let's say we have minus 12 minus c raised to the power 2 times c raised to the power 4 over minus c raised to the power 3. Alright, so minus 12. Now the power 2 here does not affect the minus 12 because the 12 or minus 12 is not inside the bracket. So the 2 only applies to minus c as shown with the bracket. So it means minus 12 will remain alone. Then because minus c has what? It's just like saying minus 1 times c. Do you get that? So it means this will be a positive, right? C raised to the power 2 times c raised to the power 4. So because the denominator has an odd integer, so it means it's going to be minus and then c raised to the power 3. Are you with me? So and then we see that the minus up there can cancel the minus below. So we can now combine them with the first and second law, which is c raised to the power 2. The multiplication here becomes addition. Then the division, because c is below, c raised to the power 3 is below. So we can also combine that together at once. So you have 12 c raised to the power 2 plus 4 is 6. Then you have this as our final answer. Alright, so we'll go to the next one. Alright, so the fifth law says nth root of p raised to the power m equals p raised to the power m divided by n. Just know that whatever it is in the root, we divide the power that is inside the root. Do you get that? Let me see that again. Whatever the root is, nth root, maybe square root, cube root, whatever the root is, the value we divide the power of whatever is inside the root. Now let me explain that with an example. Let's say we have cube root So let's say we have cube roots. So cube root of 27, x raised to power 3, y raised to power 6, and the root covers the whole number. So what are we going to do in this case? Now we can, since we know that 27 can be written as 3 raised to power 3, we can just go ahead and do that. But the number cannot be written as in index form, so we just leave it as the power of 1. So 27. Now let me just show you how I arrive at that. I believe you should know that we have been taught LCM before. So 3 in 27 is what? You have 9. 3 in 9 will give you 3. 3 in 3 will give you 1. So that means 27 is 3 times 3 times 3, which is 3 raised to the power of 3. Remember we said law 1, they all have power of 1, right? So 1 plus 1 plus 1, we have 3 raised to the power of 3. So back to the question. You have cube root of 3 raised to the power of 3, x raised to the power of 3, y raised to the power of 6. So the moment you remove the root, now pay attention to what I just said now. It means you will remove the root, the cube root rather. Now the moment you remove the cube root in this case, the power of the root, or let's say the nth root, we divide everything that is inside. I mean the power now. So you have 3. So this will be 3 divided by 3. X times x raised to the power 3 over 3 times y raised to the power 6 over 3. I hope you get that. It's quite simple. So this will give you 3 raised to the power 1. Oh, sorry, but there's a mistake here. This should be 3. So you have x raised to the power 1, y raised to the power of 2. So your answer will be 3xy squared. Alright, I hope you can see this. Y squared. Looks like my pen is misbehaving. Alright, so let's do one more. We have a fourth root of 81, a raised to the power 4, b raised to the power of 8, c raised to the power of 24. Alright, so in this case, 81, can you write 81 as a number raised to the power 4? Of course you can. So that is 3 raised to the power 4. So you can just use the method I use here. 3 in 81 is 27, and so on and so forth. So you have 4 roots. So you have 3 raised to the power 4, a raised to the power 4, b raised to the power of 8, c raised to the power of 24. Alright, so when you remove the roots, so every of those power we get divided by 4. So times b raised to the power 8 over 4 times c raised to the power 24 over 4. So you have 3 raised to the power 1 times a raised to the power 1 times b raised to the power 2, c raised to the power 6. So your answer will be 3a b raised to the power 2 c 6. Law 6, x over y raised to the power minus 1 is y over x raised to the power 1. Now a quick way to remember this is, you know that you roll it and change the sign. So it means when you roll, that is when you rule, I mean your numerator becomes denominator becomes numerator. So the sign of the power will actually change. It's as simple as that. So let's say you're asked to evaluate this. Now you can evaluate this without actually rolling or changing the sign, but it's much easier to do when you actually when you roll and change the sign. Now you have, so this will give you So this will give you 3 over 4. Now it will now be raised power of what? Of 2. It should be 3 raised power 2 over 4 raised power of 2. This will give you what? 16. Sorry. Pardon. It will give you what? 9 over 16. I really need to do something about my pen. Alright, so let's do 2 more examples on that. Okay, so you have 16 over 9 raised to power of minus 1 over 2. Okay, so now the best way to go about this is what? You roll it and then you change the sign. So let's do that. So you have 9 over 16 raised to the power of 1 over 2 now. So the sign will have changed. So that means now we can write 9 as an index of 3, right? 3 raised to power 2. Now 16 can be written as either 2 raised to power 4 or 4 raised to power 2. But because we can see that what is outside the 1 over 2 is 1. What is there is 1 over 2. So I think the best way to put this will be 4 raised to power 2. If you put it as 2 raised to power 4, you still get the same answer anyway. So you have this, you have 1 over 2. So now you open the bracket, which will give you 3 raised to power 2. This will bring in the power 4 raised to power 2 times 1 over 2. So 2 will cancel 2. 2 times 1 over 2 will give you 1. So you have 3 over 4, which is our answer. I hope we understood that. Alright, so let's see if my pen works better now. Okay, I hope you get that. So one more on that. Now we have to simplify simplify 32 over 50. Now raised power of minus 3 over 2. Now if you look at this question, it's a bit tricky. Why did I say that? Now if you look at 32 and 50, you can write them as index form, right? But you can see that there is a number that can actually divide them, which is 2. So if the numbers are divisible, that should be the first thing you do. You divide them before you now think of writing as or expressing in index form. So if you divide this by 2, you get 16. Divide this by 2, you get 25. So all raised to power minus 3 over 2. So now let's roll it now. Oh, that should have been the first thing we do anyway. So you have 3 over, is the sign you are changing, you're not changing or rolling the power as well. Okay, so now 25 is what? 5 is power 2. Then 16 is 4 is power 2. All raised power 3 over 2. So you can now open it. So you have 5 raised power 2 times 3 over 2 divided by 4 raised power 2 times 3 over 2. So 2 cancel 2. So you have 5 raised power of 3 over 4 raised power of 3. So your final answer will be 125 over 64. Then you can change it to a mixed fraction. Alright, so I go to the next law. So law 7. Alright, so p raised to the power of minus 1 give you 1 over p. It's as simple as that. So when you see that the power is negative 1, you just put 1 over it. So let's say you have 7 raised to the power minus 2. This will just give you 1 over 7 raised to the power 2. Do you get that? So remove the minus, is just 1 over whatever is there. So this will give you 1 over 49. So as simple as that. So let's do one more on that, since this is quite simple. Let's say you have 64 raised to the power of minus 3 over 2. Now there are 2 ways to do this. Now you could just say 64 over 1. Not 2 ways, they're actually the same anyway. You could say 64 over 1. Now you can now say, oh, let me roll it and change the sign, which is the previous law, right? Or it's the same thing as saying just 1 over 64 raised to the power 3 over 2. I hope you get that. Alright. Okay, so let's say 1 over 64 raised to the power 3 over 2. Now 64 can be written as let's say, so 8 times 8 is 64. So that would be the simplest way to, or the best way to express it. You can express it as 2 raised to the power, 4 raised to the power. But since the power we are dealing with here, or the denominator here, is 2. So you have 8 raised to the power 2 times 3 over 2. So you have 2 raised to the power 2. You have 1 over 8 raised to the power of 3. So that means we would have 1 over 512. Which is, if p raised to the power m divided by n equals q raised to the power x over y, then you can express p as q raised to the power x over y times n over m. I hope you get that. Now this is what we do. Let me explain that. Now, this is the explanation. Now, you have P raised by M over N, right? So, what can you multiply with M over N that will give you 1? It's just the inverse. N cancel N, M cancel N. This gives you what? P raised by 1. But whatever you do on one side, you must do on the other side. So it means you now multiply Q, the power of Q as well, with the same thing that you multiply the power of P with. So that is how it came about. P is what? Q raised by X over Y times N over N. Alright, I hope you are getting this. So, let's do a few examples, 1 or 2. So let's say you have K raised by 3 over 2 equals 64. So we are looking for K. So let's find it. So now we want K. So it means we want K to have a power of 1. So what you do is what? That will be what? 64 will be in linear form is what? 4 raised power 3. Right? Okay, so let's still leave the power here. So both are now in index form. So you have K will now be what? 4 raised power 3 times the inverse of the power of K. So K will be what? 4 raised power 2, which is 16. I'll do one more. So it says if 1 over x raised power 4 over 3 equals 2, 5, 6. So we have to find x. 2, 5, 6. Alright, so what we'll do is now 1 over x can be written as what? So we have to find x actually, not 1 over x. So what we can do in this case is we can write x as x is power minus 1, then 4 over 3 equals 256. Okay, so you should remember the law. When you have minus 1, when you have a power of minus 1, it is 1 over. So you can also go back. Each of these laws, the converse is also the case. You get, so it's not just a one-way thing. So it can go forward and backward. So you have x is power minus 4 over 3 is 256. Okay, so 256 as index will give us 4 raised to the power of 4 x. So let's go to the previous board. So x is power minus 4 over 3 equals what? 4 raised to the power of 4. Then, so now what are we going to multiply with in this case? Alright, so just look at this. Now we want x to be raised to the power of 1, right? So we need the inverse of minus 4 over 3. Are we together? Alright, so what are we going to do? We'll multiply with what? minus 3 over 4. This is what will give us 1. Do you get that? Alright, so okay, I think there's another way we can go about this. So 3 over 4. So this will give us what? So it means our x will be 4 raised power minus 3. So x will be 1 over 4 raised power 3, which is 1 over, that should be 64. Alright, but we can just do it straightforward. Let's try that. So 1 over x, 4 raised power 3, so as not to bring confusion. So let's do it straight away. So this will give you 1 over x. So 4 over 3 times 3 over 4 is 4 raised power 4 times 3 over 4. So you have 1 over x, that's power 1, everything you cancel, you have 1. So you have 4 raised power what? 3. So you have 1 over x equals 64. Right? So if you change this, x over 1, you have 1 over 64. You get that? Or cross multiply, that works for you. So you have 64x equals 1. Divide both sides by 64, 1 over 64. Now law, so we just review the laws here, then we start solving questions. So you have, if p raised power of m is p raised power of n, it says what? Then m equals n. Yes. Now pay attention here. It means when you have the same base and then you have, and they are equal to each other, but then the powers are different, it actually means the power are the same. For them to be equal, since they have the same base, it means the power are also equal. Exactly. Alright. So let's do an example. So given that, so if you are given this 256 minus n plus 1 equals 64 2n plus 4. Now how can we solve this? So we have to find the value of n. So find n. So how can we look for n? Now don't try and say you want to multiply both sides by 1 power here, because if you look at it, this is minus n plus 1. So it's not like it's a fraction or a whole number. So what you do here is you express the terms in what? Index form. Okay, so 1 over 256 can be expressed as an index of 4. 64 can also be expressed as an index of 4. But in case you cannot figure that out, so just start dividing 256 by 2. You get, so you get 2 raised power something. I think that will be 2 raised power 8. Then 64 will give you 2 raised power of 6. You get, it's still the same. I hope you just get what I said now. So 256, 2 can go, so stop. Just keep dividing by 2 until you get 1. So that will be 2 in 8 places. So that's 2 raised power 8. The same goes for 64. But then the best way to do this is to express in terms of what is it called now? 4. So you have 1 over 4 raised to the power of 4. Then minus n plus 1 equals 4 raised to the power 3. Now pay attention, you have to put brackets because there are already values outside. right? Good. So now most people make mistake if because they don't use bracket. You can use bracket a lot. If you learn how to use bracket, most of your mistakes will actually be reduced, especially when you're dealing with algebra. Do you get that? Alright, so let's continue. So 1 over 4 is power 4. When you remove the 1 over, the 1 over is actually negative, right? One of those laws, so don't forget them. Those laws, they work together. So you have 4 raised to power 3 into 2n plus 4. Now we can now open the bracket. So you have 4 minus 4. The same thing applies here. Use bracket. Without the use of bracket here, you would eventually get it wrong. Definitely. So now you can see that the base are the same, right? 4 equals 4. 4 is power a lot of variables because 4 is power some other variables. So it means we are not cutting it. Pay attention. Don't say 4 cancel 4. No. You are only equating it because the base are the same. So you have minus 4 minus n plus 1 equals 3 2n plus 4. So if you open the bracket now, minus 4 times minus n. Remember I explained here, minus times minus will give you what? You have plus 4n. Minus 4 times plus 1 will give you minus 4. Then you have 3 times 2 will give you 6n. You have to know those basics because they will always reoccur. 3 times 4 is 12. So you now collect like terms. So 4n. Now this is plus 6n. When it crosses the bridge or goes to the other side, it becomes negative. Equals, you have 12 on this side, but then there's a 4 on this side, on my left hand side. When it comes to the right hand side, it becomes positive 4. So 4n minus 6n, this will give you what? Just say 4 minus 6. So you have a credit of 4, a debit of 6. So it means you will still be in debit, right? Okay. So you have minus 2n equals 16. Alright. So what do? So you have minus 2n equals 16, right? This cancels this. 2 cancel 2. So you have n is what? Minus 8. I hope that's clear. Alright. So alright, so I'll do one more on this law before we go to the next one. So find k if given that 0.5 is power inside settings k minus 2. I hope you can see this, times 1 over 4 is power k plus 4 equals 0.125 is power 2k plus 1. When you see decimal, change it to fraction. So this will be 5 over 10. I believe you should know how I got that by now. In case you don't, just do this way. The decimal, you remove the decimal, what do you have? 0.5, which is 5. Now, divided by what? How many number comes after the decimal? Is 1, so that is 10. More like your decimal becomes 1, then whatever number comes after the decimal, you write it as 0. So you have multiplied by, you have 1 over 4, you have k plus 4 equals, the same thing applies here, you have 125 over, the decimal becomes 1. So how many digits? 3. you have 2k minus 1. So what can we do here? Okay, so if we divide this, 5 can go here 1, 5 can go here 2. So you have 1 over 2 raised to k minus 2. This can be written as, sorry about that. This can be written as 1 over 2 raised to 2, right? K plus 4. Now 1 to 5 can be written as 5 raised to 3. You don't know how I got that. Just take 1 to 5. What can go in 1 to 5? 5. Just draw a table. 5 in 1 to 25 is 25. 5 in 25 is 5. 5 in 5 is 1. So the same here you have 10 raised to 3. 2k minus 1. So you can write this as 2 raised to minus 1. But because there's a power before you use a bracket, I said that earlier, then you can also write it as 2 raised to minus 2, right? Because there's 1 over. Whatever is outside before we go in the bracket. Now, this can be written as, because 3 is common, right? You can factor it out. If you remember one of those laws that says that when you have a power outside of a bracket, you can actually bring it inside. But in this case, we need to what? To get it out. Yes, like it's stopping us right now. So you have 5 over 10 power 3 into 2k minus 1. Alright, so let's go to the new page. So we have 2 raised to we have minus 1 into k minus 2, then times 2 raised to minus 2 into k plus 4. Then we have I hope you can see that there's 5 over 10, right? We can also call this one 2. Okay, so what is 1 over 2? I hope you can skip that step. That's 2 raised to minus 1. So it will give you 2 raised to minus 1. But there are powers there before, right? To multiply 3. So you can just write this as 3 into 2k minus 1. Alright. So what you can do is that, now you can't equate this yet. That's where the question is going. When you see a question like this, they want you to actually equate that the base of the power. But you see, if you look at your left hand side, you see that you have 2 different numbers, or let's say variables. But then it has what? Multiplication. So it means you can combine it. That's the first thing you need to do. So 2, you have minus 1, k minus 2. The multiplication becomes what? Addition, right? Okay. So what you need to do is what? Use another bracket. Now, I could just tell you what that is, but I want us to follow the due process. So that's right. We have 2 raised to minus 3 into 2k minus 1. Alright, so you have equal base now, right? So you can equate the power. So equating the power, what do we have? You have minus 1 into k minus 2. So you can just open it. Plus times minus will give you what? Minus 2, k plus 4, plus minus 3 into 2k minus 1. So open the bracket. Minus 1 times k is what? Minus k. Minus 1 times minus 1 is what? Plus 2. Minus 2 times k is what? 2k. Minus 2 plus 4 is what? Minus 8, which is what? Minus 3 into 2k. That's minus 6k. Minus 6 times minus 1 is what? Plus 3. So just collect the like terms. You have minus k minus 2k. When you bring minus 6k to the left hand side, you have plus 6k. Then all the other numbers will go on the right hand side. So your plus 2 becomes what? Minus 2. Or you can combine them before you do that. Then you have plus 8. So so minus k, debit, another debit of 2k. That's, you have a debit of 3k, right? Then you have a credit of 6k. So we used to be in debit or credit now. You be in credit. That means what? You have 3k. So 3k equals what? 3 minus 2. That's 1. 1 plus 8, that's 9. So we divide both sides by 3. So you have 3k over 3. You have 9 over 3. So you have k equals what? Plus 3. That's a theory question. Something in the honest. That's why I showed you. So let's go to the next law, which is the last one. Right, so it's similar to the one we just did. So that's law 10. It says if p raised by m equals q raised by m, now both are m now. So then we ignore power and equate the base. So where are we? Alright, so let's see. It's more like the first one. In that case, you have the base the same. You're equating the power. In this case, you have the power the same. You're equating the base. So it means your P will be equals to Q. Simple as that. So let's solve some examples on that as well. So the first one says solve for M. So it says you are looking for M. You are given that M power 4 plus 64 1 over 1024. 1024 is 4 raised to the power of 5. So that's what we're writing. Okay. So we have M power 4, 0, 4 is power 3 into 4 is power minus 5. Right? So we combine M is power 4, 0, 4 raised to the power 3 minus 5. M is power 4, 0, 4 is power minus 5. Okay? This does not actually has to do with that. Okay. This is what you can do. You don't need power of 4, right? So you have M raised to power 4. There are two ways you can do this. Actually. You can just, based on the previous laws, you can just say M times 4. What's the inverse of 4? 1 over 4. So you multiply minus 2 to 1 over 4. But you want to use this new law we are using. So it means you want this minus 2 to become 4. Right? Okay. So what can you do to make it 4? 4 can be written as what? 2 raised to power 2. Alright. If you are just using 2 to begin with, it will have been more clear. So we have -2, right? 10 raised power 4 over 2 raised power -4. 10 raised power 4. I believe you know what to do. Just right? That the powers will be the same. So I guess so we solve one more in that. So find okay. So this is k raised power -4, right? -1 multiply the 4. Or let's do it properly. Then can 81 be written as a number raised power 4? Yes, 3. So that is 1 over 3 raised power 4, right? So we have k raised power -4 equals 3 raised power -4. So therefore k equals 3. So we've come to the end of the laws. So I'll bring some examples, we'll solve some miscellaneous examples, but that will be in the next video. If you find this video helpful, make sure you like, subscribe. You can also share with your friends who maybe are preparing for an exam, or maybe your siblings, children who want them to learn about this, or people who are maybe preparing for an exam, or just want them to know about what we're talking about here. So also you hit the like bell button so that you know the next time I release a video. Thanks for watching. Once again, my name is Samuel, and I will see you in yet another video with more teaching and classes like this. For actually for personal class, that's also available, but it means you have a gadget that if you're not in my location, you can do that through online. It means as I'm teaching, you are privileged to see what I'm doing live, and then you get to ask me questions and interact personally instead of through my videos. So if you're interested in that, just check. There's a way to message me, and you see that in the link in the description. Alright, so thanks again for watching, and I will see you in the next one.